Okay, we're in section 4 of the notes. It's the lecture portion. It's introductory limits. Certainly, we'll go through the notes with you. I want to say initially when we're doing limits were introduced to you in Math 119 when you were looking at rational functions, and you use limits to graph rational functions. Of course, we're going to have a more precise understanding of limits now, but it's not going to be the ultimate definition of limit. And I'll just go through what we're doing is, one is we're going to have a numerical idea what limit means. We're going to have a visual idea what limit means. We're going to have an intuitive idea what limit means. And that is, we're not going to be doing numbers and we're not going to look at a picture. We'll just have an intuitive idea. Intuitive idea really depends on your ability to understand algebra and trigonometry, right? And then there's going to be the fourth way, which we don't do, which is the epsilon delta definition. We're not going to go there. What we're going to do is we're going to try to grasp onto what a limit is, but it's really not much different than when you were told in Math 119. So I'm going to say basically a limit, and we'll kind of read this through to you. It basically, we're going to approach something. X will approach a number A. A is some finite number. And then we're going to wonder what happens to the function when we get close to A. But the problem we get close to something is you're not going to touch it. What happens when you tell someone not to touch it? They're going to touch it eventually. Here's the deal. All right. So we're going to hope that we come up with that we come up with a number L, which stands for a finite number for the limit. And there's going to be some notation you'll be familiar with. Again, this is pretty much universal. If we write A is some finite number. If we put a minus sign above it, that does not mean negative numbers. This means from the left of A. And we'll go through this by example. The next one up says plus. What does that mean? From the right of A. We will go through examples to explain what left and right means. But this is not unlike what you've done in Math 119. They've also approached numbers from the left and from the right. And where was that done? The rational functions when they were doing asymptotic behavior. All right. So the bottom line, after they talk about this, they talk about, well, gee, what does it mean when you don't have a plus or minus sign there? It means they're coming from both the left and the right. All right. So over here, it goes on, it says that for the limit, and I'll read it to you, the limit is x approaches A of f of x equals L, if and only if both the left and the right agree on or equal to L. All right. We also talk about when L goes towards infinity. All right. By the way, this is not a finite number, so it really doesn't exist, but we still want you to say it's an infinity. And when L, which is that limit, that's not a finite number, so the limit doesn't exist, but we still want you to write down a minus infinity. And we'll talk about that. All right. So the other thing is, when X goes towards infinity, well, now the A is not a finite number, but you know what? The limit could be finite. Did you do this in Math 119? You did. You did this for horizontal asymptotes for rational functions. So you did this in 119. All right. So let's keep going. We'll do the example. I'll talk through it. We'll talk about visuals. We'll talk about tables. We'll talk about intuition as well. All right. So, my bottom line is over here. After we do that, we'll go over here and we'll start doing the examples. Right. The examples are going to require the use of technology. Not all of them, but some of them will. We're encouraging you to use tools that you prefer to use. What tools do I have offered up? Well, a limited set of tools for you. But the bottom line is, if you want to use a different tool, please use a different tool. But you need to learn to use tools. All right, let me go to the whiteboard and do another share with you. Give me a second to get this displayed for you. All right. So what we want to do first is just read. And this is the part where we're going to encourage you to read. All right. So let's take a look at this over here. So this is a definition. And let's write this down. I'll do it in green. Definition. And this is the definition of the thing over here. Again, this concept was introduced in Math 100. The way we're going to read this is this. The limit of f of x as x approaches A equals L. That's how it's read. Here's the deal. It says, if we can make the values of f of x arbitrarily close to L as we like, by taking x sufficiently close to A on either side of A, but not equal to A. So let me go through that with you. I'm going to say this is L. That's some number. And what we're doing is we're getting close to A. So L is some number. And what number is the number f of x? All right. What are we doing over here? We've got a function on an interval, and there's a number A over here. All right. From the left means we're coming in from this side here, left. And this is the right side. All right. So what are we saying? We're saying that, F is going to get close to that L when we get close to A. So I'm going to put like an image of what that might look like. I'm not saying it is, but let's say f of x looks like this. Now, when we get close to A, it's going to get close to that line L. Now, by the way, I'm not saying that f of x has to look like this, but that's one example. So what are we doing? We're getting close to A. That's along the x-axis, by the way. And f of x is really the y values or y-axis. We're just saying it gets close to L. Let me point out what I mean by that again, using my little pen. This is F. We're getting closer and closer to A, but F is getting closer and closer to L. On this side over here, this is the right side. We're getting closer and closer to A. We move that direction from the right, and the function is getting close to L. All right. So let's take a look. And I'm going to say it's going to be tough to grasp it. It is. If there's anything in calculus that really gets people upset, it's limit. But here's the deal. Everything we do in calculus is connected back to limit, everything. All right. So our big goal here is to have some understanding what limit means. Although initially it's difficult to grasp, I want to tell you the notation basically says, get close to A, but don't touch it. So that's critical. So get close to A, but do not touch the A. What happens when you tell people to get close to something, but don't touch it? Well, eventually they're going to start to touch the thing. Their hands are going to be all over it. Here's the deal. We got to be real careful about this. All right. So I'm going to say, in a sense, we're taking A and like almost making it godlike. Don't touch it. Don't touch it. Don't ever pretend to be it. All right. Here's the deal, though. As time goes on, your mindset is going to start to, what happens if I touch A? Would something blow up? Right. But I got to tell you something. It's still forbidden. That A that we're getting close to, forbidden fruit, don't touch it. All right. You may want to touch it, but I'm warning you, don't touch it. You know what's going to happen, though. We're eventually going to start touching that, the forbidden fruit. It's just human nature. All right. So it says, don't touch A, don't touch A, don't touch A. All right. I hope you realize that A is along something and it's one dimensional in nature. So we got only two sides to it, one dimensional. It's either on the left side or the right side. Okay. So we have this notation, left-hand notation. This is red. X is getting close to A from the left side. Well, let me put that down again. Whoops, sorry about that. A, you know, so I get a circle around that? Don't touch it. Left side. What does left side mean? It does not mean negative numbers. It just means to the left of A. It means numbers that are smaller than A. Let's do the next guy. And again, we'll go through other examples as well. We got a right-hand limit. What does that mean? That means we have a number line. We're looking at the number A, but we're to the right of A. That does not mean positive numbers. It just means numbers that are bigger than A. That's all that means. Now here comes the part where we're going to look at the left and right, but we'd like to know what the limit as X approaches A is. And this is the part where some students get confused. For that to exist and be a number L, I want to point out L is a finite number. This could only happen if the left and the right are agreeing, and both must agree, and they both must be that number L. Whatever that number L is, it's got to be the same number. What is L? It's a finite number. If L is not finite, it could be infinite. However, if it's infinite, it still is a does not exist type problem because our limits must be finite. However, we like to see down plus or minus infinity. Let's go next page. Here's the problem over here. Sometimes when we approach A, the limit does not go towards a finite number. It blows up without bound. That's DNE, does not exist, but we still want to see infinity down, all right? Sometimes when we approach A, it doesn't go towards a finite number, it goes towards minus infinity. That's not a finite number. Now, where'd you do this? It should look familiar to you. You did it in Math 119 when you did vertical asymptotes. The key concept of vertical asymptote was if they were going off to infinities or minus infinities. And you did that already. All right, next up, in Math 119, you also did things like this. You let X go not towards a finite number, but towards infinity, and you got L. Well, when was that done in Math 119? When you were doing horizontal asymptotes. You also went towards minus infinity. Again, the limit exists, it's L. All right, let's take a look at an example. As I do these examples over here, I want to point out for some students, these are incredibly painful problems. Over time, though, life should get much easier for you. So what I want to do is I want to go back to Math 119 and talk about what you do in Math 119. In Math 119, the teacher says, oh, factor the problem. Then the teachers in 119 would have said, hey, maybe it might be a good idea to reduce it. I want to tell you, this is only true. This is true if and only if X does not equal -1. And why is that? If X were -1, it'd be canceling a 0. That's bad news. Then the teacher said, okay, just graph out 1 over X -1. That's fairly simple to do. Let me go through that with you. And we'll talk about what you did in 119. There's a bunch of things you did. One of the things the teacher said to do is, any x-intercepts, y-intercepts. People do get these things wrong, but I'm hoping you're not. And I'm going to say over here, a lot of students would say an x-intercept. Well, let me put the y-intercept down first. That's easy, right? Y-intercept. How do you get a y-intercept? Set x to be 0. What would you get? I'm just reviewing Math 119 now. If we said 0, what would you get? You get 1 over -1, which is -1. I plugged it in there. If you plug it in here, what would you get? Well, you get 1 over -1 is still -1. So I know I got a point here. Now, x-intercept. A lot of people are going to say, oh, x is -1, then y would be 0. And why is that? They're looking at this. Unfortunately, this is not true. And I'll tell you why it's not true. If x were -1, the top would be 0, but unfortunately, the bottom is simultaneously 0. So there's no x-intercept. None. All right. What am I going to do next? I'm going to do vertical asymptotes. A lot of students in 119 would say, oh, it's x equals plus or -1. But again, I'm going to communicate to you, that's not so. All right. But we'll go through that. I'm going to say there's only one vertical asymptote, and that vertical asymptote would be x equals 1. Let me clean that up a little bit. But then this is 1. Okay, we'll talk about why -1 is not a vertical asymptote later. All right, but x equals 1 is a vertical asymptote. What did the teacher tell you to do now? They told you to do this. They told you to take a look at the limit as x goes towards infinity. Well, I got to be honest with you. We're so far away from -1 that I feel pretty safe in doing this. And what would you get over here? 1 divided by an infinitely large number, which would give you what? 0. All right, before I go on, not that we're expecting to do at this stage of the game. You did not do this in 119. You didn't talk about the side it came from. But I hope you realize if x goes towards infinity, the bottom is a positive number. So this will definitely be from the top of 0. Limit x goes to -infinity. Well, the bottom again blows up without bound, so it's still 0. But the bottom number is always negative, so this will be through the bottom. So I'm going to put the asymptote in. This gives me an asymptote. What kind of asymptote? Horizontal. HA, they called it in 119. And that's going to be y equals 0. I'm gonna plop that in for you. Again, we're just reviewing what you did in Math 119. And let's take a look at this. I'm gonna put the graph down now, and not the full graph, by the way. But as we go towards infinity, it goes towards a zero through positive numbers. As we go towards minus infinity, it goes to a zero through negative numbers. That's what these symbols over here are indicating. Now, granted, I'm not saying you did that in 119, but what you did in 19, you definitely did the horizontal asymptote. We'll talk about what you did in 119 later. What I want to do is I want to do the vertical asymptote, though. And what I'm going to do over here is I'm going to look at this, the limit as x approaches 1 from the right side. All right, I know it's difficult. I know students even at 119 level, even taking a full 4 months of that course, have trouble with this. All right, now before I do that, I want to point out, it would be nice to know the sign of it. So what I'm going to do, I'm going to do over here, I'm going to put the 1 down. In 119, you actually started with sign analysis when you did inequalities, and it remained throughout the rest of the semester. Almost all the problems you did in 119 had something to do with sign analysis. So what's a good number after 1 to choose? Maybe 2. And what's 1 to, and again, we're checking it here. You could check it, it's going to be the same story, by the way. What are you going to get to? Would be 1 over 1, which is positive. So I know whatever this is, it's a plus number. Question is, what's on bottom then? Well, I'm going to think about it. You're getting closer and closer and closer to 0. Let me point out what I mean by that. If you get close to 1 from the right side, I'm sorry, I wrote the wrong thing down. I gotta correct something here. This is that thing up there. I gotta correct that. Get my eraser here. Sorry about that. All right. So if you get closer and closer to 1 from the right side, what are you getting close to? You're definitely getting close to 0. So the bottom is going to be an incredibly small positive number. So that's infinity. Put this over here. Now, what did your teacher tell you to do in 119 now? They said connect it. Reasonably, by the way. Let's look at another limit. Let's look at limit as x approaches 1 from the left side, 1 over x minus 1. This is the left side. So your teacher might have said, oh, sign analysis. What's a good number to the left of 1? I don't know, like maybe 0. Plug it in, what do you get? Negative. What do I now know? Whatever this thing is, it's got to be a negative number. What do you get though on the bottom? You're getting incredibly close to 1 from the left side. It's like 0.9, right? 0.99. So it's definitely going to be negative on the bottom, an incredibly small number. So it's going to blow up without bound. This over here. Then what did your teacher say? Connect the dots together. So that's 119. So I'm going to claim when you did 119, that's not a bad thing to be doing. You could do that all over again. You get the answers over here. So let's take a look at it. And I got a problem over here. They want to know what this limit is. I'm going to put a question mark. I don't know that limit. Let me see if I can do it. All right. And I'll write this down for you. And there's a variety of ways of doing it. Limit as x approaches 1 from the right. I'm sorry, it's minus 1, isn't it? X plus 1 over x squared minus 1. And that's, I have no idea. So what I'm going to do over here is I'll look at it. And that's minus 1, right? Let's look at our graph. Well, where's minus 1? It's over here somewhere. So I'm going to say something strange is happening over here. Something's really strange. Right. So what I'm going to do, I want to get my eraser out. And I want to tell you why that can't be there. Because at minus 1, I'll write that down for you. That function's undefined because it's division by 0. So I have to get my eraser out, and I've got to erase this distance over here. Let me see if I can do that. That's erased now. Now, in Math 119, what they called that was a removable discontinuity, or just simply a hole. But I think I can do that. I think I know what the hole is. And how do I do that? I just look at this guy over here. And let's write that down. What would you get over here? Well, I'll write down what I think I'm seeing. Minus 1, comma. Well, from a pre-calc sketch, it's going to be what? That's going to be 1 over minus one. So it's going to be 1 over minus 2, which is minus 1f. So I'm going to say, just for my pre-calc skills, I'm going to say that this thing over here, let me erase it for you, is minus, whoops, 1/2. All right. So let's go back over here. And yeah, I think I can do that from pre-calculus, but I want to start thinking about it. All right. Let me start thinking about this. So I'm going to write this down. Limit. This is me thinking, by the way. Thinking can be very dangerous. And I'm thinking if x is getting close to minus 1, it's never going to touch it. If it's never going to touch it, I'm going to say this thing is never going to be 0. So I'm going to go write this down now. Limit. Whoops, sorry about that. Limit. Sorry about that. Limit. X goes to minus 1 from the right. 1 over x minus 1, right? So let's take a look at this one over here. Now, by the way, you know I'm always saying don't touch, don't touch, don't touch, don't touch. But in your mind, you're getting really, really close to minus 1. So what's the bottom going to get really close to? Minus 2. So what are you seeing over here? 1 over minus 2, which is minus 1/2. All right? There's nothing wrong with that, by the way. If someone said, did you touch it? I would deny it. I'm saying I got close to it, and it got close to minus 2 in the bottom. All right? Here's the deal, though. I'm going to claim over here is that we really don't want you to do that. What we want you to do is this. We want you to do a numerical table. Put this down. Okay. I want to get close to what? Minus 1 from the right side. We're not trying to confuse you, nor are we trying to rush you. That's right side. While I'm at it, I'm also going to do left side, because I bet that's their next question. Let's take a look at this. If you're to the right, you know what? I got my left and rights mixed up. I got to erase this again. LT is left, RT is right. Let's do right side first. What's a good number to the right of minus 1? I'm going to say minus 0.9. I want to get closer. Minus 0.99. I want to get closer. Minus 0.999. What goes here? F of x. What's f of x? F of x is that nightmare, which is x plus 1 over x squared minus 1. But if you remember from my Math 118 days, I said this is really the same thing as 1 over x minus 1, provided x was not equal to minus 1. Let's put this down now. So I'm going to say you could use this one here, and you could use this one over here. I'm going to say this one might be easier for me. And let me write this down. And what are you going to get? The first number would be what? 1 over minus 1.9. What's the next number going to be? 1 over minus 1.99. I think you get the idea. 1 over minus 1.999. Where are these numbers going? Well, they sure do look like they're going to minus 1 from the right side of it. Make sure you understand what I mean by right and left, by the way. You're looking at a number line to do that. That's the right side. Where are these numbers going towards? Well, if I'm looking at that, don't do the division, by the way. I'm going to say they look like they're going towards minus 1/2. Let's do the left table. I'll write this down for you. This will be f of x. And I want to do to the left of 1, minus 1. So what's a good number? I don't know. Minus 1.1? Minus 1.01? Minus 1.001. If you're struggling with that, you want to struggle with it until you get it. What do you get over here? Well, I'm going to use this thing again because it's so easy to use this thing again and again. What do you get over here? 1 over minus 2.1, 1 over minus 2.01, 1 over minus 2.001. Where are these numbers going towards? Minus 1 from the left side. And where are these numbers going toward? I hope you can agree they appear to be going towards minus 1/2. All right. So I'm going to say it's not that bad. I mean, I think I figured this one out. It's minus 1/2. And it said it's in the notes. We also want to point out, we put the visual down over here. Same visual we put over here before. I want to point out there's a hole here. There's a hole. What's that hole going to be? Minus 1, comma, minus 1/2. If you look at the picture, I'm going to point out what I mean by that. This number minus 1x, the y appears to be minus 1/2. You see that? Okay. So I'm going to claim really not that bad if you've got the pre-calc idea. And certainly the left and right limits agree. We just did that before. And the tables are down there for you. Oops, sorry about that. The tables are down there for you. And we did both the left and the right limit. What do we know about the limit? The limit does equal minus 1/2. All right. So let me just see if there's anything else to say about that. Not really. They keep, the same thing over and over again. Let me see if I got everything I needed to put down. I got the picture. We did the picture. Their picture is pretty good. And what else they do? Very little else. All right. I know this is difficult. So what are we going to do? We need to do these examples now. All right. Some of these examples are going to involve technology. We'll talk about that after I walk through the problems first. Okay. Thank you so much for your attention. Again, I know this is tough material. I do want to suggest that if you have a textbook, please read your textbook. Please become more engaged in your studies. And that way to get engaged in studies is one is try to understand what's being presented to you, but you're going to have to go to a book sometimes. And I would say a real education requires you to go to a book. You're not going to learn everything in the classroom and classroom alone. Thank you. Also, you can come by during us hours if you really need additional help.